Welcome to our viewers. Thank you for joining us for our webinar today, Achieve 80% Cheaper Cloud Architectures for Retail. Joining us today are Adam Dagnall, a sales engineer from Cloudian.
Thank you, Jen. My name is Adam Dagnall. I'm the System Engineering Director for EMEA, and I'll be walking you through the webinar today with a focus on how Cloudian HyperStore can help optimize retail data center architectures. So in terms of a rough agenda for today, we'll start off with our perspective on some of the market drivers in the retail space. We'll then zoom in and spend a little bit of time talking about the importance of the S3 API, and then we'll go a little bit deeper and talk about the HyperStore architecture, and then have a look at some of the features and benefits of our products, with some time at the end for questions. So the primary objective of today's webinar is really to demonstrate to you how retailers are saving, up to 70% and beyond of their data storage costs with Cloudian HyperStore. There's a number of different areas here where HyperStore can help organizations save money, whether that's repatriating workloads away from AWS and other public cloud providers, or reducing backup and data projection costs by eliminating the ingress and egress charges associated with the public cloud, optimizing Hadoop Big Data workloads, saving storage costs for Splunk with Splunk SmartStore, as well as tiering snapshot data from pure storage systems such as FlashArray and FlashBlade. And finally, moving to a modular and scalable architecture that eliminates forklift upgrades and is well suited to the long-term retention of data. So some of the observations that we see in the market really kind of focus in on a couple of different areas. So I think one of the points here is really around cloud adoption maturity. We see a lot of organizations who originally invested in public cloud solutions now looking for alternatives with a generation 2 or 3 approach, really moving to more sort of hybrid and multi-cloud architectures, as many of the workloads that are out there today are not really optimized for the public cloud. Another area here is retailers moving away from those public cloud providers as they are not seen as trusted partners. And I sort of mentioned this with regard to Amazon's acquisition of Whole Foods, putting them in a slightly different position and potentially competitive position to other retail organizations that are storing data within their cloud platform. Another area we see, another observation, is a number of organizations have invested in high-performance flash and hybrid type solutions that are really designed to offer platforms that are architected for high IOPS and low latency workloads, transactional workloads, which obviously provide a very good platform for those particular data sets, but actually where the growth is in the unstructured data actually don't provide the same level of benefits. They can't really address the demands around capacity and some of the features around deduplication and compression don't work so well on these unstructured and encrypted data sets, certainly when we're talking about things like encrypted databases or multimedia content. And really the third observation we see here, the third shift, is organizations really looking for a different type of platform that can deliver high efficiencies at scale. Very often these organizations are looking for a platform that can deliver global namespace across multiple geos, and really giving them something that can, serve their purpose for, extended periods of time, eliminating those traditional forklift upgrades that you associate with primary storage systems such as SAN and NAS-based platforms. So if we look at the market and we look at, the explosion of data that we're seeing, this capacity growth, if you sort of zoom in and take a look at the numbers, 90% of all the data that's out there today was created in the last 2 years, and of that 90%, the bulk of it is actually unstructured data. So we're storing more data than ever before, and with that comes increasing challenges around complexity, managing that data, as well as initiatives to try and drive towards multi-cloud and hybrid cloud strategies. So just wait for the slide to catch up here. So when we talk about those traditional primary storage systems, again comparing to SAN and NAS platforms, if you have a single storage array, it's pretty easy to manage. If you have a few storage arrays, it's doable. It becomes a little bit more challenging. But when you get into hundreds of terabytes and petabyte and potentially exabyte scale, these type of solutions become very, very difficult to manage. They become difficult to manage for a couple of different reasons. One is the life cycle of these technologies is limited. It's finite, typically between 3 to 5 years, and then you have to replace these systems with the next generation. And of course, when you replace them, you typically have to migrate your data from platform X to platform Y. This can take time, it could introduce downtime, and it can introduce risk into the environment. The second challenge is really around efficiencies. Very often, organizations protect their data using RAID. They replicate these data sets to secondary systems, and then spin these data sets off to tape, and then off to a van, and then to an off-site location. So for every gig of data that you're looking to protect, very often you have 8, 9, 10 gig of actual raw storage underpinning it. So a platform like HyperStore really changes the game, operates in a different way, provides a different model. And although you could argue cloud storage offers a partial solution to this explosion in data growth that we're all bearing witness to at the moment, there are a number of arguments why on-premise storage is still essential. Performance is typically going to be a lot quicker with an on-prem storage solution. Issues around security, compliance, and legality can be addressed with an on-premise storage solution such as HyperStore. But ultimately, I think the biggest driver for us is cost of access. Because although on the face of it, public cloud solutions can appear attractive financially, actually when you get into the detail and you get into the weeds and you start looking at the egress costs of pulling your data back out of these type of systems, very quickly the costs can begin to stack up. So I'm going to spend a few minutes just talking about S3. S3 is Amazon's simple storage service. It is the storage element of AWS, Amazon Web Services. It is also the API, the mechanism for getting data in and out of the object store. And S3 has actually been around for quite a while now. It was launched in 2006, and it really dominates the public cloud market. Amazon, AWS are actually bigger than their next 14 competitors combined, so they really do dwarf the competition. And the API as a standard is really quite advanced and offers a lot of features and benefits over and above what you can achieve with a standard, block-based protocol such as, ICE, SCSI, or Fiber Channel. So what HyperStore is effectively is a scale-out, software-defined, S3 compatible object storage platform that looks and behaves like AWS S3, sits behind your firewall and operates at a better price point. And there are a number of different use cases that make sense for an object store such as HyperStore, whether that's offering storage as a service, and we have a number of multi-tenancy features that enable us to play in this space, whether that's quality of service, chargeback reporting, or role-based access control. Use cases around backup and archive, providing a highly durable storage platform for these data sets, or use cases around analytics, and we'll spend a moment or two looking at Splunk and Hadoop use cases at more depth. So some of our features are called out on this slide here. One of the things Cloudian does very well is S3 compatibility. We offer the most complete and extensive support of that standard outside of AWS. We have a very modular system that can start pretty small with a 3-node cluster, and then you can grow that system out via the addition of cluster nodes. And as you add more nodes in, not only do you gain more capacity, but you're also able to drive more performance through our scale-out architecture. We also have very granular controls around how we protect the data with different data protection techniques, as well as options around encryption and compression, and also being able to control data placement within certain geographies depending on the cluster topology. We also have an interesting story around multi-cloud and hybrid cloud capabilities, whether that's moving data into the public cloud or replicating data into the public cloud, or even running in the public cloud to provide an S3 gateway capability for public cloud platforms that don't natively support that particular API. We're flexible in terms of deployment and have a number of different options, whether we're running on physical hardware appliances as a software-only model, or even running as a virtual machine instances for small deployments and some of those public cloud workflows I mentioned a moment ago. And of course, we do all of this whilst operating at better than public cloud pricing. So lots of different use cases make sense for an object store such as HyperStore. And one of the big benefits of this type of platform is the fact that your applications connect to a single namespace, which is typically a URL address, something like S3, yourdomain.com. And the applications themselves, they connect using a REST-based API, which in our case is S3. And what this means is really any application that can take advantage of HTTP or HTTP access can take advantage of this type of storage platform. Whether that's a backup application or a sensor or some kind of device that has a native HTTP or HTTPS capability can take advantage of this type of system. And I think that's one of the reasons why the public cloud has really dominated over the last decade or so, is because of the number of devices that can talk HTTP and HTTPS. So a few slides here really just to talk a little bit about object storage and what it is and what makes it a little bit different from block and file-based solutions. There are really 4 defining characteristics of object storage, and the first is really the scalability of the platform. We don't have any of the limitations that you associate with a block and file based type solution, and that's due to the fact that the underarching structure of an object store is flat, and for every piece of data that is stored there is some associated metadata, and that metadata can in fact be as rich as the data itself that we are storing. The other distinction that makes object is the way that you get data in and out of these platforms, and I've touched on this already. it's typically using a REST-based API, so S3 in our case, but really anything that can take advantage of HTTP or HTTPS. And the last defining characteristic is the way that the data is protected in an object store is different to those block and file-based solutions. Typically, block and file-based solutions use RAID subsystems to protect the data, whereas in the object world, we protect data using a concept of RAIN, redundant array of independent nodes. So as an object comes into the object store, we either create copies of that object and store it on independent nodes, or we break that object up into fragments, add some parity, and then each of those fragments are actually stored on independent nodes within the system. So it's a concept that's similar to RAID, but done in a thin provision manner across multiple nodes within the system. So because of that, object stores don't have the same limitations around capacity. They can grow far larger into the petabyte and exabyte scale. And the other main difference here is when a component within the object store reaches the end of its duty cycle, its life cycle, it can be managed out of the system non-disruptively, and new hardware components can be managed in. So just to take a step back, really where object makes sense is for these unstructured and semi-structured workloads. We're not a platform that's designed for high IOPS or low latency, so you wouldn't be running database applications or VDI workloads or applications actually on the object store. It's really the design there for the unstructured data sets. And if you have a look at an object, if you zoom in and take a look at an object within an object store, the object being an X-ray of Homer Simpson's head here, there's really two types of metadata. You have system metadata, which is kind of typical as to what you would find on like a NAS file share, so things like, you know, the name of the file, the date the file was created, the size of the file, when it was last modified, all that kind of standard stuff. And then you have the option of defining your own user-defined metadata, which typically comes in the form of key-value pairs. So in the example here, we have patient, Homer, age 50, scan of brain, and so on and so forth. And as I say, this user-defined metadata can be as rich as the data that you're storing. And the key benefit here is that metadata is actually decoupled from the data itself that we're storing, which in this case would be the blob, the JPEG or the TIFF, the actual file itself. The metadata is stored separately, and in our case is stored within a distributed database across all nodes within the cluster. And what this means is you can take the metadata independently of the data, you can export it, you can index it, you can run analytics on the metadata without having to actually touch the data itself. So if we're talking about very large objects, very large files, we can pull the metadata out without having to pull the very large data sets out themselves. And if we take a look and focus a little bit on, you know, what S3 is and what it brings to the table, it is a REST-based API, but it offers a lot more than a traditional standard storage protocol such as block and file-based technologies. If you look at something like Fibre Channel or iSCSI, it doesn't really give you much more than a basic read-write capability, whereas S3 has a whole load of additional functionality layered in on top. So things like access control, tiering, encryption, this is all built into the S3 API. And as I've mentioned already, we offer the most complete and extensive support of that standard outside of AWS. We're pretty much as close to AWS in terms of S3 support as you can get. Some of the roadmap features that we're talking about today include things like S3 Select, which is a relatively new feature from AWS that allows you to run transactional SQL commands within the S3 API call to extract meaningful data from the data that's stored within the platform. And I mention this because for a vendor to claim S3 support, really all they need to do is the basic operations, of which there are around 6 or 7 basic API calls, such as a get and a put, which is similar to a read and a write, where actually there's over 80 API calls that make up the S3 command set. And we support around 94, we're about 94% compatible with S3. So whereas other vendors are talking about things like versioning and tiering on their roadmap, this is stuff that we've been doing for a very long time. And the other key differentiator here is we are 100% native S3, and every node within our cluster is able to service an S3 request. Other platforms in this space, other architectures typically have their own proprietary API with gateway modules that are bolted in on top that kind of do a translation from the S3 connector to the native API, and stuff can get lost in translation. And the reason why all of this is important is really down to application support and compatibility. There's a vast ecosystem of products and services that are out there that have been developed to talk S3. And very often when we're talking to organizations, when we're talking to retail customers, we're really talking about use cases that are driven by applications. And just to zoom in a little bit on specific use cases and applications that support those use cases, we can see on this slide, whether it's big data and analytics with the backup platforms where we're going in as a replacement for tape. Pretty much all of the backup vendors today, certainly the tier 1 backup vendors today, support S3 out. NAS offload, being able to take data sets from existing primary storage systems and move them onto a cost-optimized capacity tier such as HyperStore, based on things like the frequency of access and policy, make a lot of sense. It's a way to reduce and optimize those primary storage systems and move data to the right place at the right time, effectively reducing the cost. Sync and share type platforms, things like Satera and SME and Ignite, all supporting S3. And then things like analytics and machine learning, deep learning, those type of workloads, as well as a play on security as well. So there's lots of different areas where this type of platform makes sense. Very often we'll start talking about, a specific use case. Perhaps we start talking about backup. And then after, some discussions with the prospect or customer, we can identify a number of different workloads that are already in place that would benefit a move on to a capacity optimized tier such as ours. So I have a slide here on backup. I've mentioned already most of the backup vendors now support an S3 capability, and really this enables us to go alternative to tape very often. HyperStore has a number of native features that enable us to replicate data between data centers. So for organizations that are looking to move away from tape, but they still want to take advantage of off-site data protection, we can go in as a platform that helps facilitate that. So effectively, backup servers move data to an S3 bucket in a primary data center, and then HyperStore replicates that data across to a secondary DC. And obviously the benefits of having your data on an object store over tape means that in terms of recovery, that process is a hell of a lot quicker, and you can get data back much faster than you would do if the data was located in an offline archive sitting on tape. Another use case that's very relevant with our type of platform is archive. And the primary difference between backup and archive is that archive is the only copy of data, whereas backup is a secondary or tertiary copy of the data. And obviously when you're storing data within an archive, you want to have a very high level of data durability. And with a store such as ours, we can drive durability numbers up to 14 nines and beyond. And there's a number of different areas, a number of different ways we can achieve these archive workflows, whether it's through a file gateway type approach where we're presenting out a CIFS and NFS share using something like Hyperfile, which is our own file gateway technology, or using one of the NAS offload engines I mentioned earlier to move data away from those primary storage systems onto an object store such as ours. Splunk is an interesting use case. Splunk has recently introduced a new feature called SmartStore, which allows you to scale your storage infrastructure independently of the compute resources that you have, your Splunk indexes. And this helps significantly reduce cost, certainly when we're compared to the public cloud alternative. Pure storage is another use case where we see increasing demand, and we kind of have a number of different plays here, primarily around flash array and being able to take data that is stored within snapshots and effectively store it within the object store. So again, really sort of cost optimized storage for those snapshots that can be used for recovery, and then optimizing the the flash array, reducing the amount of storage that's actually stored on the flash array to effectively optimize and extend the life of that platform. So I'm going to talk now a little bit about the HyperStore architecture. And there's really a number of different ways we can deploy HyperStore. We can provide hardware appliances that are pre-configured and tested, or we can run as software only and really install on any x64-based archiptecture. If we look at our hardware-based appliances, we have two models that are available today. We have a 1U appliance, the HSA 1500. This has 12 high-density disks that are used for the object storage, as well as a couple of SSD drives that are mirrored that we use for the operating system and Cassandra database that we use for metadata. But other than that, it's just standard stuff. So in terms of connectivity, everything's driven through Ethernet. We typically have a front-end and a back-end network. The front-end network is used for S3 payload and administration, and the back-end network is used for inter-cluster communication and replication. We also have a larger model for denser footprint. So this is our HSA 4000. It's a 4U box, contains 70 drives and 2 compute nodes. So each compute node within the chassis is responsible for 75 drives. And again, it's all standard stuff, standard CPU, memory, standard Ethernet networking used for the front-end and back-end networks. And effectively, we start with a 3-node cluster, and you can keep adding additional nodes into the system, and it looks and behaves like one device. So as you add more nodes in, you immediately get more capacity, you're able to deliver more throughput, and you're actually able to unlock additional protection schemes. And one of the benefits of our platform is the ability to actually mix and match different size nodes within the same architecture. So you could start potentially with 3 1U appliances, and then actually scale that solution out by adding the bigger nodes if your capacity requirements change dramatically over time. In terms of some of our naming conventions, we're kind of similar to AWS in the sense that we have a concept of a region, and within the regions we have logical data centers, and within those data centers we have nodes. And this can really be as complex as your environment. The slide here is showing a single region system with 2 DCs. You might have 3 data centers, 5 data centers. It really doesn't matter. As I say, it can be as complex as your environment, but you manage the entire estate through a single pane of glass. It is effectively a single scale-out cluster. And we can support various different techniques for protecting the data that's stored within the system. So if we start in the top left-hand corner of this slide, we talk about something called a replication factor, which is where we're creating copies of the object. So if we're storing a JPEG, and we're using an RF3, each node within the system will get a copy of that JPEG. So we can lose 2 nodes and we still have a copy that we can read back from. If we look to the top right of this slide, we introduced something called erasure coding, which is similar to RAID. In fact, this particular scheme, 4+2, is similar to RAID 6 in the sense that as data is written in, it's broken into fragments. We have 4 data fragments and 2 parity fragments. And it means out of these 6 nodes, we can lose 2 of them and we can still read our data back. So this operates at a higher efficiency. This is 67% efficient as compared to 33% efficient with the replication factor. But it still gives us a good level of durability because we can lose 2 of the nodes and still read the data back. And it's worth pointing out at this point that, node failure, catastrophic node failure to the point of non-recovery is a very rare event, and it doesn't really happen. But of course, we are very often the archive store, we are the single copy of data, so we need to be able to drive very, very high levels of data durability. So we can take this concept of erasure coding in the top right, and we can mirror that across sites, which is shown in the bottom left-hand corner. And this means in this scenario, we can actually lose a DC and a couple of nodes at the surviving DC and still have enough fragments to read our data back. So out of these 12 nodes, we can actually lose 8 of them and still have enough fragments to read our data back. And then the last example that we show in the bottom right-hand corner is distributed erasure coding. And this really takes this concept of local erasure coding and distributes this across multiple DCs. And what this really gives you is a good blend of durability and efficiency. This operates at about 57% efficiency, and it means that you can lose an entire data center and still be available for read-write requests. Now, this is a nice protection scheme, but it's not for everybody because you do need to have multiple DCs, a minimum of 3, and you also need to have a high bandwidth, low latency network in order for this to work effectively. On the back end, we have what we like to call a peer-to-peer mesh. All of the nodes within the cluster are functioning as peers. All of the nodes are running the Cassandra database, so they have access to the metadata. All of the nodes are running our CMC, our management console. All of the nodes are able to service S3 requests. So as the requests come in, they are load balanced to all the nodes within the cluster. There's no single point of failure. The data is protected in line with the protection scheme that you specify at the bucket level. And of course, the data is protected within the Cassandra database that's running on all nodes within the cluster. One of the benefits of a scale-out solution such as ours is as you add more nodes in, you're not just adding additional capacity into the system, you're also adding more compute resource, more networking resource, more memory into the system. So we're able to deliver more performance as more nodes are added in. Again, just to take a step back, we're not designed for the high IOP, low latency workloads, but when we're talking about throughput and sequential workloads, we're actually able to deliver very, very high levels of throughput. So the example on the slide here is showing a 6-node cluster using our 1U appliances using an RF3. And under the right conditions, we can achieve around 5 gigabytes of read throughput, which is pretty impressive. And as you add more nodes into the system, that number continues to increase. And due to our level of S3 compatibility, we're able to take advantage of features such as multi-part upload, which enable us to break up very large files into smaller segments and basically parallelize the workload so that we're able to send multiple streams simultaneously and distribute that across all of the nodes within the cluster to help drive additional performance there. So a lot of the features that I'll talk about here are really S3 features that we've implemented. So if we focus and talk a little bit about security, there's a number of different areas that we have features in that really play to this space. So role-based access control is inherent and built into the system, along with access control lists that we can set at the bucket level. We also offer support for IAM, which is Amazon's identity and account management service. In terms of network security, I mentioned at the beginning, data is ingested and egressed through HTTP and HTTPS, so we can effectively force all of the traffic through HTTPS for data in flight encryption. For data at rest, we have a number of different options around how we protect the data, so we can use AES 256-bit encryption for data at rest. And then we support things like worm and versioning errors and accidental deletion, rogue admins, and those type of soft errors. In terms of encryption, we behave very much like AWS, so we have the option of doing client-side encryption, actually having the data land on us in an encrypted format. If we're talking about things like rubric-type workloads, Rubric will actually do the encryption, and then the data will actually land on us in an encrypted format already. Or we could do server-side encryption or server-side encryption with customer-provided encryption keys, in line with the AWS S3 implementation of this feature. So we do it the same way Amazon does. And also we support key management systems such as KeySecure and AWS KMS for additional wraparound auditing capability and functionality for encryption. One of the features we have that AWS doesn't is compression, so we're also able at the bucket level to enable various different compression algorithms that can help squash the data down even more and help drive some additional efficiencies for long-term retention of data. We support versioning, which can be enabled at the bucket level, and in effect what we do when we enable versioning for a bucket is we make all of the data within that bucket immutable. So if I have a file that I'm storing within my S3 bucket and I modify that file, I will end up with the original file plus the modified version of the file. So it allows me to roll back to the previous version. If I delete the file, I just put a marker in that I put the delete. I don't actually do the delete. So again, this helps protect against soft errors, accidental deletion, ransomware, rogue admins, and all of those types of threat. And a level up from versioning is something called worm, which is write once, read many. And this means I can enforce a policy on my S3 bucket so that data is retained for a predetermined period of time. So if I set a worm policy on my bucket for 7 years, it means all of the data within that bucket needs to be retained for 7 years before we can actually delete that bucket and the data contained within it. Short of taking a sledgehammer and a very large magnet into the data center, there's no way of actually deleting the data that's stored within the bucket itself. I mentioned multi-cloud at the beginning, and there's really a number of different ways we can talk to multi-cloud with HyperStore. Built into the product, we have a native tiering capability. This means we can move data from your local S3 bucket into the public cloud, be that Amazon, Microsoft, Google, or really any S3 platform that supports the tiering capability based on policy. So I can have a bucket and say any data within this bucket that's not been accessed for a year, move it into AWS. And then when the data is tiered into the AWS S3 bucket, we still hold some local metadata. So you can either retrieve the data locally through HyperStore by clicking on technically the stub file, and we'll pull it back, or you can log into the AWS console, log straight into the S3 bucket, and pull it out, directly through AWS. And the nice thing about when we tier the data into any of the public cloud providers is we keep the data in its native format. So we talk about bimodal or converged data access. You don't have to go through us to get the data back. You're not locked into HyperStore. It's stored in its native format. So as well as being able to replicate or tier data into the public cloud, we also have the option to replicate data into the public cloud using cross-region replication for those public cloud providers that support that functionality. And we also have an option of actually running in the public cloud as well. So Microsoft Azure doesn't natively support S3. So one of the slightly more unusual use cases for HyperStore is actually running as an S3 gateway for Azure. So actually spinning up some virtual instances that are running in the Microsoft cloud, providing near 100% S3 compatibility, and then immediately tiering that data in that converged bimodal form into Azure Blob. So really not storing any data on those virtual instances, just really acting as a store and forward gateway. So that if you have a number of applications that have been developed for S3, and you also happen to have a whole lot of Azure capacity available, you can point those applications at the instances that are running in the public cloud. So various different ways we can carve up that multi-cloud discussion. In terms of multi-tenancy, there's a number of different things that we do here, and we've had great success I should say, in this space with service providers and also organizations that are looking to offer storage as a service across departments. And this really boils down to 3 or 4 key areas. So role-based access control, having different levels of access into the system with a self-service portal with an S3 client built in. Quality of service controls that enable us to set limits around users and groups within the system. So those limits are really around capacity and throughput and number of requests, as well as chargeback reporting. So you can actually build out your own Amazon-like rating plans and then charge back based on the type of protection scheme that you're using. So really these features combined, as well as our per bucket protection schemes, make us an ideal choice for service providers. And this slide here really just shows some of those quality of service controls that I mentioned previously. These can be applied at the user and the group level, and they allow us to set limits so the user and group can consume, the number of requests, and the amount of throughput. So, this is useful if you're a service provider. It's also useful if you have 3 or 4 different workloads on the same system. You might have a backup workload, an analytics workload, and a file-based workload all running in parallel, and you might want to restrict the amount of throughput that your backup application can consume so that it doesn't get in the way of those other workloads. And of course, all of this is programmable and scriptable via our API. So in summary, why do customers choose Cloudian? Well, first and foremost, said already, we offer the most complete support of the S3 standard outside of AWS. We have no limits on scale. You can start pretty small and grow virtually without limit. We have very granular control around how we protect the data within the system, so per bucket protection policies also extend to things like compression and encryption and tiering and replication and the other features that I mentioned. We can set those all independently at the bucket level. We're very flexible in terms of how we can deploy our solution, whether it's an on-premise solution across a single site, across multiple sites, a hybrid solution that's tiering into the public cloud or replicating into the public cloud, or even a configuration that spans, an on-premise element and instances that are running, in the public cloud as well. That's also an option that's viable potentially if you have the required networking infrastructure in place. And finally, we have a number of cloud features. I think it's fair to say we're a feature-rich platform, a number of options around multi-tenancy, multi-cloud, QoS, billing, security, and obviously with our close to 100% compatibility with S3, more and more features being introduced on a daily basis. And just a final slide here with regard to Gartner and their Peer Insights website. Cloudian has the highest rating of all object storage companies, as well as the most reviews of object storage vendors.
Okay, excellent. I would like to thank Adam for his time today and to our audience for joining us. You can also find more info on our website, Cloudian.com. Thank you again for joining us.